This is going to be a soil report review for the Fairfield Garden Initiative. My name is Faith Reeves. I do soil health, garden, nutrition consulting for those who aren't in the Fairfield Garden Initiative and are viewing this later, viewing the recording later. That's who I am. I also do some soil health guidance for the Bionutrient Food Association and do that independently as well. So today we're going to be going over 5 soil reports, and we're going to look at those from the perspective of the chemistry of the soil. I'm going to go into what type of soil report we are utilizing, and then why that is a great snapshot in time and some of its pros and cons, what it's telling us and what it's not telling us, and then how some of our visual skills can be utilized to make some of those additional assessments when it comes down to looking at the health of our soil structure, soil function, and our plant health. That tells us so much. So again, if you have any questions throughout the process, feel free to pop those into the chat. I would ask if everybody, for the quality of the recording, if everybody could mute themselves now, so that the quality of the recording is good. And then if you have questions, we'll open those up towards the end. I'm going to go through each soil report. Because I was the person who got to visit your garden and take your soil sample, I've got some of that inside knowledge as well from your soil and your plant health. And then I've also reviewed your intake forms. And so those points will be brought up during this as well. And my hope is to be able to answer all of your questions during this session. I find that it is a little bit easier to provide you with the recommendations in a more condensed email form. And so I'll make recommendations for amendments that should be applied this fall, and then amendments that should be applied in the spring. Some management practices to consider in the way we do our soil disturbance or mulching, and things to think about for the fall as we're going into winter. And we're also going to talk about cover crops. If you're interested in cover crops, I will make those recommendations. And then, of course, those that are members of the Fairfield Garden Initiative program, we have resources available. I'm going to do my best to try to shunt resources towards all of the individuals who are going through the review process. And then we'll just meter those out as we can, respectfully trying to make sure that they go far and wide. The type of soil report that we're looking at from Logan Labs is a standard soil test. And so what you do, I'm going to share my screen now, just so you can start to get a visual of what I'm talking about. But the soil report that we're looking at is a standard soil test. It's a Malic 3 extraction solution, and the Malic 3 extraction solution has a pH of 2.5 to 2.6. So it's acidic, but it's not extremely acidic. So it's not giving you a insight into what is in deep reserve in your soils. It is giving you an approximation of what microbes and plants using acids could extract from the matrix that is your soil. So whether that is a non-soil media, whether it was a bagged media that didn't have any sand silt clay, or a compost-based media, or if it's sand silt clay, that is where the soils originated from, or parent materials that are slowly broken down over time by microbes in assistance to and by plants in order to make nutrients available to the plants. We are, as are most microbes, not able to produce our own food. We're not autotrophs. We don't take sunlight and turn it into carbon and supply ourselves with food like plants do. Plants are very unique, and some microbes can do this as well. Some photosynthetic microbes can actually take sunlight and transition that into a carbon source, and then they can trade that as a currency. And so that standard soil test is basically giving you best guess as to what that partnership between microbes and plants could provide to plants from the parent material that your soil is made from. So whether that's a sand silt clay, including soil, or if it's a soilless media. We are dealing with home gardens here. And so home gardens can be a mix of both. Some raised bed scenarios are going to still be in contact with the native soil or the indigenous soil below that raised bed. And so the media that's placed on top of that soil is still accessible to those plants and the microbes that live inside of it. If you're dealing with a raised bed that is elevated off the ground and you didn't include a topsoil or a sand, silt, clay, including media in your mix, then you have just a different scenario. You'll get some advantages and some disadvantages there. Those of us who are dealing with gardens that are directly into the soil, that we're just topping with compost or mulch, have a more direct relationship with our soil's parent materials, which is wonderful. They're all great, and they all can use a little support from additional amendments, but we still need to, well, my perspective is that we still need to be working to build the relationship between microbes and plants, maximizing photosynthesis, and then building the quality of that soil over time, building the nutrient holding capacity of that soil over time, and building the nutrient load in that soil over time. All of those nutrients in a soil, especially the nitrogen, the sulfur, the carbon, they all have cycles. And we're not looking to create a perfect soil report. We're not trying to balance the soil report out to a T and have it be 100% an ideal soil. That's not the goal. The soil itself is, it's a dynamic thing. It's constantly in flux. And so if we are able to work with the biological system, if we're working with plants, especially working with seeds that are direct sown into our soils, I'll talk about why that's a great thing to do in a little while. If we're working with well-made composts or inoculants or native microorganisms, if we have a soil that still is inhabited, extraction, that 2.5 to 2.6 pH extraction solution. And so they're taking the soil that I sent to the lab and they're running it through this process where they do the extraction and then they run it through a ICP. It's a device that's able to count the extracted cations and anions from that solution. Again, not the only type of soil test that's out there, and there is no perfect soil test. So you can have a deep digest done on your soil, which is using a much stronger acid down to like a pH of 1. It's a nitric acid. I like to have for grower clients or for clients that are looking long-term, if they're going to stay in their property long-term, having a total digest done on your soil is a way to look at what is in deep reserve. It's not a geological assay, but it is a stronger acid that's digesting that soil and looking at the larger bulk pools of nutrients. And so, yes, like on this soil test, we're seeing that you have 31 parts per million of phosphorus, but I would almost guarantee you that you have 4 to 10 times this much, if not even more. Same with the potassium. You'll have more of the sulfur. You'll definitely have more of the calcium and magnesium. You'll have more of what is being expressed here, just because it's a stronger acid. And those stronger digest soil report or soil tests are looking at something that microbes could get to over time, but it's in reserve. They're not going to be breaking that down anytime soon and making it all plant available all at once. It is something that you can look at and say, okay, I've got enough phosphorus to last my garden for the next 2, 4, 6 generations. I have enough of this where I don't have to worry about adding any more. When we have excesses in our soil, we can start to have, they can be as problematic as deficiencies. And so some of our elements in our soil are going to be in excess, depending on how we treat our soil and what we're amending with, or how it's been treated in the past, or what its parent material is. And then we're also going to have the same in the way of excesses. And both of those can be slightly problematic. And so we're just trying to get towards a balance of a quantifiable, known, happy medium, kind of the Goldilocks principle. But when I'm doing a soil analysis, I'm taking information that I've gleaned from the William Albrecht's perspective, from Arden Anderson's perspective, from Graham Sate's perspective, from Michael Estera's perspectives, from John Kemp's perspectives. It's an amalgam. And so it's experience over time, watching how a soil functions and how nutrients are made available to the plants, and are the plants happy and healthy. In many cases, we can have a really imbalanced looking soil report and very healthy plants as long as the biological system is functioning well. So here we're looking at Muna's soil report initially here, and right at the top, this is the total, or that's the TEC is what it is. It's the total cation exchange capacity. And so when they do that extraction and they're pulling those elements off of the colloids, off of the exchange sites on the parent material, they're taking the positively charged ones and they're making the calculation for those. And so that's where they're coming up with, it's like we had this much calcium, magnesium, potassium, sodium, zinc, manganese, iron, aluminum. We had this many positively charged elements in that extraction solution. And so this is the assumed exchange capacity. We don't have a soil test right now that gives us an anion exchange capacity. So cations are elements that are positively charged. Anions are elements that are negatively charged. And that is kind of just the way of everything. It's all charge and energy, the magnetic world. Everything is somewhat energy dependent. And so that charge is what holds these elements onto the soil or the parent material. It's usually clay. Clay is a negatively charged soil particle. And our positively charged holding or exchange sites are going to be our organic matter, our soil organic matter that's more broken down, that's been microbially digested into more humic-based compounds. Those are going to have more of those positively charged exchange sites, and that's where the negatively charged elements can reside. And so that's sulfur, that's phosphorus, boron, molybdenum. You'll see through all of these soil reports that sulfur tends to be low, and so does boron. Both of those tend to leach with our annual rainfall. We have somewhere between 34 and 37 inches of annual rainfall a year. And when we have that type of water moving through, percolating through the soil, it's picking up those anions. It'll pick up some cations as well, but the anions tend to leach. Nitrate is an anion. It's a NO3. And so NO3, it's an anion, negatively charged. And so it leaches. So if we have more organic matter, more microbially digested organic matter, not organic matter that's just particulate of plants that hasn't been pre-digested, once it's been digested through the body of microbes or through the body of earthworms or organisms, then it has much more of that holding capacity. And so the mulch that we place on the surface of our soil is wonderful as an armor or a barrier for our soil, one, to prevent our water from evaporating off the surface of our, or out of our shallow profile, but it also is a UV protectant, so our soils don't oxidize. Anything that's exposed to oxygen, 21% of our atmosphere is oxygen. If it's exposed to oxygen and it's exposed to UV, then it's going to oxidize, which means that the carbon that the microbes have fixed in our soil is actually volatilizing and going back into our atmosphere as CO2. So that's one reason to keep our soil covered. Ideally, we're keeping it covered with a living green canopy with living roots feeding the microbes at all times. And that's why cover crops are really important, even over the winter. But if you don't have that opportunity, keeping it covered with a plant-based mulch, and then slowly but surely the decomposer organisms like the earthworms, the macro and micro arthropods, those little springtails and the roly-polies, they're going to slowly break down that plant material and make it into small enough particle sizes so that the fungi and bacteria can actually get working on it. Fungi and the bacteria are the ones that are going to actually turn it into that stable soil, organic matter, and stable carbon. And so that just takes time. So here we have an exchange capacity in this soil report of 20, which, because we have a pH that's above 7, I'm thinking that this is a little bit skewed towards the high side. That is because we're taking a really acidic extraction solution and we are digesting a soil that natively or naturally has a high pH. It's going to have high magnesium, high calcium, high potassium, high sodium excess that's not even held onto that colloid, onto those exchange sites. So it's picking up extra of that. These elements, this calcium, magnesium, potassium, sodium, they are positively charged. These are our base cations. When you see the base saturation in percent, the base cations are calcium, magnesium, potassium, and sodium. They are alkaline. And when we have a pH that is tilting towards the alkaline, it's more than likely because we have excess of some of these elements. And so over time, biology will rectify this. It can be amended with a more acidic element like sulfur, which is more acidic. It can be amended with sulfur, or not sulfur, but more acidic inputs. You can use peat or pine needles or things like that. You can even use acidic oriented or reduced composting setups, like if you're using effective microorganisms. You can even use, there are several organisms that you can utilize to pre-digest your compost if your pH is too high. But really, it's kind of like, yes, those are awesome. And yes, we do need sulfur here, so we'll add a little, but don't sweat the pH. It will continue to regulate itself as the biology picks up and as the amendments become a little more in balance. So as you're adding a little more sulfur over time, it is going to pick up some of those excess. You'll see in this soil report, we have excess magnesium. It'll pick up some of those excess magnesium ions, connect to it. Sulfur sulfate is a negatively charged ion. It's going to attach to or absorb to a magnesium, and then they will leach or percolate down through the soil profile. And so slowly but surely, some of that will become moved down through the soil profile and not as readily available up in the top rooting zone of your soil. I'm going to take a drink of water. So we've got an organic matter. And so just for context here, this is a covered soil. This is a hoop house. And so this soil is not readily leached. And so that's something when you're looking at a soil report, everything has context and it's nuanced. And so whenever you're looking at a soil report, it's good to know those nuanced bits of info. So this particular soil is undercover. And so we definitely want to be cautious with anything that's applied to the soil because it's not going to be leached anytime soon. The only water that's going to be applied there is going to be done through irrigation. And so there's not going to be the winter 3 feet of snow that melts and percolates down through the profile and takes some of those extra elements down with it. It's not going to have rain events for the same. And so in a hoop house over time, if amendments are being applied, things can build up. And very often you'll see that sulfur and sodium and zinc will start to build up. And so being mindful not to make any aggressive applications. And I don't like to make aggressive applications anyway. I like to be really cautious when applying to the soil and let the plants and the microbes kind of work it out, work with amendments that are really microbially friendly. But just keeping that in context that we do have a covered soil here. And so, yes, we're going to need some sulfur, but slowly that'll be added. And so a little bit of elemental sulfur in here is something that I would do for this fall because you also need phosphorus. And I know that you have manure to work with, and that's great, composted manure. But I think an additional bit of phosphorus might be a good idea just to kind of bump this up a little bit. This 218, again, this is just my little algorithm that I use to assess a soil. And so it's based off of your exchange capacity. When I know your pH is high, I do an adjustment here. And so this has already been adjusted for what I assume your exchange capacity is, but still, this is an ideal, and this is something that you're working to over time, many years. It's not something that you're trying to achieve next year, and you more than likely couldn't achieve it next year without really kind of choking up your soil. And so I think that applying the manure on the portion of the composted manure on the portion of the greenhouse that is not going to be planted early next season, and then working with the cover crops as well. But I think utilizing a rock base like a Tennessee brown rock or a soft rock phosphate input would be great for this fall to help bring that phosphorus up. And I would blend that together with the sulfur and a little bit of carbon and a little bit of boron. But when I make your recommendation, I will go into detail about that. Great. Yeah, thank you. So when this was taken, it was not undercover. That is great. Thank you for adding that. And that's one reason why that sulfur is not so high potentially, and also that your sodium is not so high. Both of those can really creep up when they're undercover. And so I'm glad that you had that flush. I would love to see that every greenhouse had an opportunity to have the plastic pulled off and allowed to flush or have water percolate through it, at least for one season or two, if you could allow something to rest. These are home garden scenarios, so we have a little more breathing room. We can move our garden if we needed to. If some individuals have a little extra space, they could expand their garden in one way and put something into a cover crop for a season or two if needed. Or if it's kind of hard with greenhouses, once you commit to getting the plastic put on, it's usually an expensive endeavor. And so you want to leave that plastic on until it needs to be replaced. And that can be 10 or 11 years, depending on the quality of your plastic. So just be mindful, Muna, when making applications. And manure-based composts can be high in sulfur, in sodium, in potassium, and in phosphorus, also in zinc, other elements as well. But I see those really affecting a soil report. And so being mindful when applying those, that you are conscious of those potential excesses, and then leaving that awareness in place perpetually if it's undercover, working with rock-based inputs to help bring up specifics. The phosphorus helping do that with like I said, a Tennessee brown rock or a soft rock phosphate will help. They are something that are only very minimally available, can be only like 3% available to the plants initially when applied, but they're going to be broken down over many, many, many years. And so you'll have a metered amount of phosphorus, provided that you have the microbial life to work on that over time. It will continue to provide phosphorus to your plants, but we need phosphorus in the beginning of the growing season for rooting, for root development. And when our soils are cold and we are trying to get them up and running, phosphorus solubilizing organisms aren't necessarily active and really going for it quite yet. Phosphorus can be a real problem early in the season. And so using some blended techniques for making sure you have enough phosphorus, but also being very mindful that phosphorus is same with potassium and nitrogen. When those are applied in excess, they actually can deter microbial engagement with plants. And so mycorrhizal fungi are one of the organisms that is very well known for making phosphorus available in the soil to plants. 95% of the plants on the planet associate with mycorrhizal fungi of some sort. Most of our crop plants are associating with arbuscular mycorrhizal fungi or endomycorrhizal fungi. They are not as prevalent in agricultural soils as they would have been before we started managing our soils the way that we do. And so considering using an inoculant in order to ensure that the spores or the propagules are in close proximity to the seed or the rooting zone of your plants is really advisable, especially when you're first getting something established or if you have never used them before. Mycorrhizal fungi are known to provide a plant with all of the known essential nutrients and others and water. They're kind of the keystone species of the mycorrhizal or the microbial community, in my perspective. And they have a consortium of additional microorganisms that they associate with that help them do their specialty work. Providing phosphorus is what they're most well known for, but they again provide all of the other essential nutrients that a plant needs. Not all plants again associate with mycorrhizal fungi, but there are other microbes like actinobacteria that do similar work for those plant families that don't associate with mycorrhizal fungi, like brassicas or chennopods, the spinach family. And it's good to have all of those plants in a system. Having diversity of plant species and microbial species in order to maximize the nutrient cycling in our soil is ideal. So I think here, yes, using at least for another fall or two, utilizing the composted manure, but do another soil test within 2 years after those applications, in addition to using a rock-based phosphorus input, and then know that you can utilize in season, early season, you can utilize micronized foliars, micronized phosphorus foliars. Another technique that I would love everybody to consider utilizing is making sure that you have legumes established in your growing areas early in the season. So if you're not going to do perennial legumes like alfalfa or clover in your growing systems, consider having fava or a winter field pea or something of that sort in your cover crop mixes, and then checking to see that you have something in the legume family actively growing in the spring. Those plants have relationships with microbes that are really good at breaking the calcium phosphorus bond, and they start that work early. And so you can actually get some of that phosphorus liberated for the plants that you're gonna plant in your garden. You can get that work started before your transplants even come. And so you can have some really nice microbially mediated plant available phosphorus right there in the rooting area, available for your plants for uptake in the spring, if you utilize either a perennial legume or a cool season legume in the spring. So here your calcium is good. You're pretty good on calcium. And so whether or not your plant's going to have access to that, we'll see. Calcium is a double positive. Phosphorus is a triple negative charge, double positive on the calcium, triple negative on the phosphorus. They bond very tightly together, and it's a bond that's very hard to break. And so you don't have enough phosphorus, I assume, to lock up all of your calcium. I'm sure your plants are going to be able to get access to that, especially if you're using the cover crop and keeping it very biological, you'll get access. But that early season is when you really need that calcium coming in. You need calcium every day, every 24-hour cycle for plants, especially when they're actively growing. Calcium is really important for making healthy cell walls. Calcium, boron, silica, very important for making healthy cell walls. And so we want to make sure that your plants have access to calcium. Calcium is an element that is hard for plants to get access to because it is with that potential bond here, but it also can bond to other negatively charged elements, but it also can bond rather tightly into the soil, and the plant has to release hydrogen in order to get access to it, which is not a hard thing. It does that all the time if it's photosynthesizing well. But if it doesn't have enough boron, if your plant doesn't have enough boron, it then is having a tough time getting access to the calcium. And so we'll definitely want to make sure that we have a little bit of a fall application of boron, and then again late winter when that spring application or late winter application comes around, making sure there's some boron in there so that your plants are going to be able to get access to that calcium. Calcium, again, really critical for structuring, for cell wall development, and it's not mobile in the plant, and so that's why it has to have new sources of calcium coming in every day in order to be able to be utilized on the newer plant tissue. It has to come in every day. And so it's just important to keep that biological activity going in the soil. Your magnesium is a little high. Magnesium, calcium, there's a ratio, could be 5 to 1, could be 7 to 1. We have clay loams. We don't have much sand in our soil. Our soils tend to be rather tight anyway. And so we want to have more calcium than magnesium, more than the typical. And so a 7-to-1 would be ideal. Right now, I'm going to buzz down here. Right now, you're probably looking at I'm going to say, yeah, your calcium's pretty high, so you're not in super bad shape, but the magnesium is a little higher than we would like. It could be making your soil tight, but you'll be after the applications in the spring, you'll be at a 9-to-1, which is great. So we'll see how your plants are doing health-wise, making sure they're getting enough calcium. And that blossom end rot, if you're having tomatoes or peppers or any fruit show deformities or kind of rotting at the blossom end, that's certainly an indication of calcium deficiency. There are a lot of visual assessments that you can do to check for calcium adequacy. Here on the potassium, you do look like you could utilize a little more potassium, but I would caution against applying too much because, again, early season, you want that calcium to be prominent. The potassium can actually kind of scooch in the way. It can kind of circumvent calcium uptake. It's a smaller ionic radius. It's got a single positive charge. It's not ever bound it never becomes a organic molecule. It doesn't get locked up in structure. And so it is a lot more mobile in the soil and it's a lot more plant available. And so when we have soils that are moist, it travels in the soil solution in the water of the soil. And so when we have a soil that is moist, like we do in our springs, and we have adequate or excess potassium that's being made available in solution, the plants don't have a way to prevent uptake of potassium, and they can take up more potassium than what they need. And then you can have an issue with not being able to get the calcium to where you need it in the growing shoot tips, in the fruit embryos. And so I would caution not applying potassium in the spring. Don't applying any in the spring. So I don't think applying a manure-based compost, if you're already kind of pushing potassium, never applying that in excess because it's one of those elements that can be high in a manure-based compost because that's just the way bodies work. It's not really bound into structure. It's excreted out of a organism's body pretty easily. And so it'll show up in a manure-based compost, but it'll also show up in a food-based compost or just a plant-based compost. And so watching the potassium, and then if we're really cautious to make sure that we're utilizing the mycorrhizal fungi inoculants, making sure that our plants are well taken care of in that way, that is one of the filtering mechanisms that we can put in place. The mycorrhizal fungi colonize the root system, and they can be a filter. And they encourage additional microbes to join in that filtering process. You can see that process if you have those roots that are completely covered with soil. When you dig them up out of the ground and you kind of shake the plant a little bit and the soil clings to the roots, that's called a rhizosheath. And that's an indication that you've got a microbial community, and more than likely either mycorrhizal fungi or actinobacteria associated with those plants, kind of helping buffer some of the excess nutrients. They can certainly buffer heavy metals and just nutrients in excess. They're kind of wanting to make sure that the plants are getting exactly the right nutrition in order to be healthy because their lives depend on it. Their lives depend on their host being healthy. And so microbes like mycorrhizal fungi and actinobacteria and any of the rhizophagy, there's a whole new realm of plant nutrition or plant nutrient acquisition that's out there called rhizophagy or endophytes. They all just want their plant to be healthy. They want their host to be healthy. Just like our microbes would prefer that we're healthy. Yes, we do have some invaders on occasion that can come in and take over or at least multiply into a quantity that causes issues, a sickness or some sort of unwellness, and that happens in plants as well. It also is that sometimes those microbes that live inside the plants have a complete microbiome just like we do. There's not a millimeter on a plant inside, outside, upside, downside that's not completely inhabited by all types of microbes. if it's on the inside, if it's running through their sap in their interior structures, more than likely going to be single-celled or just not very large organisms, although the mycorrhizal fungi and the dark septate fungi do live in the cell walls of the root cells. They don't really travel, I don't think, up into the whole plant, but just saying that the whole plant itself has its own community, just as we do, a complete microbiome. And just as when our microbiome is in dysbiosis, if we have a lack of diversity, it shows in our health. Same for them. And so if we have that rhizosphere health, that those roots are completely covered with soil, it's a column of soil that covers the root systems. You'll see it more prevalently with grasses. They're really good at sending carbon down into the root system, and so they feed a lot of microbes, but all plants can develop them. We want to encourage that. We want to do everything we can to protect the rhizosphere of a seed. We'll talk a little bit about the core seed microbiome that comes with every seed. That is basically the initial starting point of that soil or that plant microbiome is in the seed itself. And so here we have a calcium magnesium ratio or the percentage of the base saturation. And so this isn't the CalMag ratio. This is the base saturation. And so basically they took that TCEC and they say of that total exchange capacity, cation exchange capacity, 68% of or 66% of that is filled with calcium, 26 with magnesium, 1.9 potassium, and 0.4 of sodium. Ideal for our soils around here, 68% calcium, around 10 to 12% magnesium would be good. And then potassium, 4 to 5% would be good. And then the sodium can go up to 1.5%. And then the remainder of that space in that 100% would be the other elements that are in trace amounts in the soil that are positively charged, like the iron, the manganese, the copper, the zinc, the aluminum, cobalt, selenium. And then also hydrogen plays a role here. If we have a soil that doesn't have excesses of these base cations, then we have a pH that's not above 7. And so because you have a little bit excess of the magnesium, which tends to affect pH quite a bit, it's quite alkaline, that is filling up those excess exchange sites. And so over time, that again can be flushed out with a little bit of sulfate or sulfur, and that will, as it's moving down through your soil profile, will bring your pH down a little bit, but that's something that you do gradually over time. The potassium, again, you have a need for potassium. The manure, the composted base or the composted manure that you have is going to be a potassium source. And so I would see what that does and then wait until the peak kind of reproductive stage in your growing season. And so let's look in May to mid-June and plan an additional very plant available potassium application to make sure that you've got that potassium. It's very important for fruit filling to get sugar into the fruit. It's very important, but you need that calcium to get access first so that you have calcium mediates cell division, potassium mediates cell expansion. You want the cell division to happen first, and you don't want it to be impeded so that you can have bigger fruits. You can have stronger cell walls on those fruit. Calcium is a very qualitative element. And so getting plenty of calcium into the early stages of a plant and then bringing in potassium when it's needed. It's easy to get to a plant. It's not hard to get potassium to a plant. And so doing a foliar application of a plant available potassium in season is a great way to go. You're just applying it in small amounts as needed. It's more targeted, more precision, but that's a great way to do it. But also, if you have a microbially active soil that is maintaining good hydration, you're more than likely not going to have too much issue with potassium. And then you can utilize additional helpers in your greenhouse when it comes down to having chop and drop mulches that are high in potassium, and that would help too. You do need a little bit of sodium. Everybody just needs a little bit. It's not considered, I don't think, a plant essential nutrient. I actually need to look at that. But a little bit would be great. It's more than likely going to come in with your composted manure. So let's just see what happens there. I, on occasion, will apply a little bit of a Redmond's sea salt to a blend. And so when I apply amendments, dry amendments to the soil, I pre-blend them to make them a little more palatable, make sure they've got a good carbon source mixed with them, so that they are buffered and very microbially friendly and attractive. So I would maybe do a little bit of this in the fall. And then, yes, definitely want to make sure you're getting some boron into this equation in the fall here. And I would do a split application, a little bit in the fall and then a little bit in the late winter. It again is a negatively charged ion, so it can leach, and so it doesn't make any sense to apply it in large quantities at once. And it also, boron, just like sodium, can be a herbicide if applied too aggressively. And so applying it in small quantities more frequently as needed, and then watch your plant health. And then just watch your soil test every other year or so. It's good to get a soil report every 2 or 3 years, especially if you're making heavy compost applications or manure-based applications. You really want to watch to make sure you're not pushing your nutrients into excess. Iron, this is not really, because of the way the Mehlich 3 is not a great way to assess iron. We have iron and silica. They are very high in the soil, in the Earth's crust, 2 of the most prevalent elements in our Earth's crust. And so we don't have to worry about them. Aluminum, iron, silica, very high in the Earth's crust. Our clays are aluminum silicates, and iron is just, yeah, we don't have an issue with not enough iron. We have an issue with our plants not being able to get access to iron. And so when we have soils that are that are bare, then our soils oxidize, and then the microorganisms that will make iron available to plants are not able to survive in that type of scenario. The plants, or the microbes that make iron and manganese available to plants, need to have a reduced oxygen environment. They need to have a more high energy, reduced environment. And so utilizing plants that can support those microbes is great. Inoculating with a diversity of microbes is great, but always keeping your soil covered so that it's not oxidizing, so that that habitat is at least conducive for them to survive. Iron and manganese are critical for photosynthesis. If your plants are not photosynthesizing effectively, then we're not doing our job. That's the whole role. That's the only way to really have healthy plants, is to have plants that are photosynthesizing very effectively and pumping sugars down into the rhizosphere and feeding microbes so that they then can be fed by microbes. Plants have evolved to be fed by microbes. They haven't evolved to be fed out of a jug or a jar or a bag. And so trying to keep it as close to nature as possible. So providing habitat for those microbes to be able to survive is ideal. Also, you can utilize cover crops that have grass species in them, like oats and rye and wheat and barley. They are hosts, especially oats. Oats are they host a lot of reducing organisms in their rhizosphere. And so they would be very supportive of making sure that iron is available for the next crop. So having a cover crop with some oats in it would be great. Manganese, you're looking good here. You don't need any more manganese. This is probably not super accurate in total. Like if you did the total digest, you would see that you have way more than this here, but this is a good amount. Again, it's whether your plant can get access to the manganese. And so manganese is critical. It's part of the first step of photosynthesis. They have to have manganese in order to split the water molecule, in order to have the energy to do photosynthesis. That splitting of the molecule is a very energy intensive process, but it's also a lot of action comes from that. So manganese, very important there. Copper and zinc. Zinc is pretty accurate on the Mehlich 3 soil report, but copper is not super accurate on this report. Ideally, I would love to see the 2-to-1, where you'd have two zinc to 1 copper. But again, this isn't right on the money, and so you may be a little higher here. Copper is a fungicide. It's used a lot as a fungicide, as a spray, topical spray for plants to deal with fungal issues. It is really supportive of the immune system of plants in order to make sure that they have balance in their microbiome, to make sure they don't have a lot of fungal pathogens. It's better if they get access to their copper in a microbially mediated way, but you can utilize a foliar to apply a little bit of these trace elements, even the manganese, the copper, the iron, zinc, cobalt, molybdenum, in a very plant available form, in very tiny amounts, just above like homeopathic amounts, just really tiny amounts. And really it's just enough to get the enzyme cofactors met for the plant. A lot of these metals, a lot of these micro trace elements are enzyme cofactors. They are needed for the enzymes to be able to be created in order to function and do the metabolic work that needs to happen. And so you need to supply it to the plant, but by supplying it to the plant then can take any additional excess or even those exact same compounds that they create themselves, send it out through their root exudates and feed it to the microbes. And so just feeding a little bit to the plant in a foliar does make sure that the soil is getting access to it. You don't have to apply a lot of soil-based dry copper sulfate or zinc sulfate or manganese sulfate. It's not needed in our soils because we have that baseline amount, I think, in our soils to make sure that our plants can get access to it. We just need to prime that pump by getting a little bit onto the plant the right time, the right type of foliar, and that helps. Same with cobalt, molybdenum. Cobalt is needed for, molybdenum is needed for nitrogen fixation. Base one, 78% of our atmosphere is nitrogen. It's an N2 gas, but plants can't access it. They have to get access to it through microorganisms. There are many nitrogen fixing organisms, or not many, but there are different types of nitrogen fixing organisms. Some associate with legumes and live in nodules on the root systems of peas and beans and alfalfa and clover. And then there are also free living nitrogen fixers that live in the soil pore spaces, in well-structured soil that is aggregated. We should talk about that, but that those organisms exist there, and they also exist inside of a plant. Endophytes, there are nitrogen fixing endophytes inside of a plant. It's new information that Dr. James White and his graduate students are coming to now, that the trichomes of plants actually house nitrogen fixing organisms, free living nitrogen fixing organisms. I don't know if they're free living if they're inside of a plant, but they've also identified that the nitrogen fixing organisms exist in the plant tissue that doesn't have chlorophyll. The plant cells that are not photosynthetic, that are kind of like the variegated parts of plants, you'll see that the nitrogen fixing organisms also live there. All inside the plant, the trichomes and that non-photosynthetic plant cells, those are low oxygen environments. All nitrogen fixing happens in a low oxygen environment. So if our soil is really oxidized, then we are not making a good location or habitat for those free living soil-based nitrogen fixers. If our soil is not well structured, if we don't have that pore space in our soil, if we don't have all of those aggregation units in our soil, the micro and the macro aggregates in our soil, those macro aggregates have pores on the inside. There's pore spaces between those aggregates in the soil that can fill with water. And that is not a place where there's a lot of oxygen. Oxygen doesn't diffuse in water very easily. And so those areas of the soil are places where the nitrogen fixing organisms live. So plants have evolved to get their nitrogen from microbes. And so applying it to the soil, just like I was starting to say there with phosphorus and potassium, nitrogen as well, when we apply that in excess to our soils, then we are negating the need for plants to build relationships with the nitrogen fixing organisms or the mycorrhizal fungi. If we supply potassium in excess, we kind of just bump out a lot of other elements. It's not so much that there are particular microorganisms associated with potassium acquisition that I know of. Of course, mycorrhizal fungi can get access to it, but if we apply those in excess, we kind of cause issues. And so that's where we have to watch our compost, because composts, especially if they're manure-based composts, are going to be really high in potassium, phosphorus, nitrogen, sodium, zinc, things like that. And so we don't want to apply it in excess. We kind of want to use it targeted and know what we're applying. Even our plant-based composts can be high. It depends on what the starting material is. And so assessing that, vermicompost can still be high in nitrogen, but it depends on how it's made and how it's kept. It can be a nitrogen form, an organic nitrogen form that is organic, just meaning it has carbon associated with the molecule, that it is not as deterring of that microbial relationship. Non-organic forms of nitrogen, nitrate or ammonium, are the two that we're watching out for. And so fertilizers, bagged or bottled fertilizers that have nitrogen in them, if they're not like a fish hydrolysate, more than likely they're going to have some inorganic, not non-organic, inorganic nitrogen. But you can manure-based composts done well that aren't over oxidized and don't have a lot of nitrate in them can be fine, but just still using it in a targeted precision type of way. You've got good silica here, not having enough cobalt molybdenum. That again, we're going to talk about foliar products for that. I think that's the best way to go here. You need it in like grams per acre or very small amounts, maybe an ounce or two per acre, depending on the form of the input that you're applying, but it's very small amounts. And so utilizing it in a well-made foliar product is more ideal. And you're applying it directly to the plant, and the plant can decide how to utilize it. Yeah. Silica, that's definitely a microbially mediated element as well. It's hard for plants to get access to enough silica, and so having a really biologically humming soil is ideal. This is just a calculation off of your organic matter, so it's letting, like, if your soil was microbially digested, this is the potential of how much nitrogen could be made available over a growing season. Again, this whole soil report is a snapshot in time. And so I took this soil from that location in August. And so it's already gone through its cycle, which was a heating and drying cycle as the plastic was put in place. It's been in a drought for a long time. And so it's not going to be as microbially active as it was before the plastic went on, but at least it had those 4 years prior to the plastic going on. Okay. And so that was a lot of talk about Muna's test, but everything I've said is still going to be relevant here for each of the following. It's nice just to get some of those words out of the way, and we're just going to go through the others and point out the highlights. And so here you've got a pH that's 6.5. And so it looks like this total exchange capacity, Kyle, this is the high part of your garden there, the topsoil mound. And so this is, let me double check here. Okay. Yeah. Okay. So I think that total exchange capacity is accurate, and that's good. We definitely want it to be thin silt clay silt clay loam here. We have the potential to have a pretty high exchange capacity. Clay soils tend to have a very high exchange capacity because of that. All of those little clay platelets are negatively charged, and that's where all the cations are held. And so the more clay you have, the more room you have to hold nutrients in your soil. But depending on the balance of the elements in there, is that soil breathable? Is it well structured? Are you able to fully utilize it? Are your roots able to really get down into that soil? That's something that you have to kind of develop over time, or maybe it's still natively in good condition. Your organic matter is good. The higher the organic matter, again, this organic matter number is basically all of that kind of suite of organic matter that we were talking about, whether it's microbially digested, stable soil organic matter, or it's the particulate organic matter that has just been broken down by soil organisms like earthworms and mites and all the little buggies. So the pre-microbially digested stuff, that particulate organic matter, is not stable. It's going to be transient. And so that's in here too. And so that's great. It's meant to cycle. That soil organic matter with microbial action over time is going to be wonderful. Pretty low on sulfur. we'll make a suggestion to do a double application, a little bit of the elemental sulfur in the fall and then some gypsum in the spring. Yeah, you do need gypsum. You need some calcium as well. And so a calcium sulfate in the spring will be great. Anything that's water soluble, I think it should be applied in the spring. Anything that needs to be broken down over time, apply that in the fall. And so elemental sulfur is something that really needs to be microbially digested. And the microbes that do that work are not really active in soils that are under 55 degrees. And so you get some of that action now until our soil temps start to cool off, but then it won't really pick back up again until maybe late April, early May. And so it can take 6 months for that sulfur to really become available. And so applying it now or in the fall would be great. And then you'll get some of it in the spring. Phosphorus, you are low. Again, this number right here is really based in general off of your total exchange capacity. And so sure, it's pretty high. That's something that you may never need to reach this number, provided that you have, I kind of feel like if you have above 75 parts per million, depending on what your system is like and what you're growing there, then kind of adjust from there. But at least 75 parts per million would be ideal of the phosphorus. So you definitely need to get a little more in there. A rock-based phosphorus product like a soft rock phosphate or a Tennessee brown rock, something that's a little more available than a hard rock phosphate. Even inputs like guanos or poultry manures, things like that are going to be really high in phosphorus. Any animal that consumes grain is going to have a manure that's really high in phosphorus. It doesn't mean that it's going to be available. It's still probably got the phytate molecule kind of safeguarding that phosphorus. And so that can be broken down over time. Be careful when applying poultry-based, like composted manure or poultry-based compost, if it's not from a source if it's really kind of like on the market bagged product, just be aware that there is a practice where they are offering, they're basically utilizing a process that breaks down, it's a heat tolerant phytase, heat tolerant phytase enzyme that they're applying to poultry feeds in order to make the phosphorus in the grain more available to the birds. And then that comes through in the manure, and then it also comes through in that pelletizing process on the other side. And so that phytase can actually liberate phosphorus from your soils and have it leach. And so I wouldn't buy, like, I don't know, I haven't heard a lot about that. That's just an awareness, just to be mindful that you could have a reverse effect from using a poultry-based, like pelletized manure, but you can make your own. You have chickens, you can make your own. Just be careful because it's real hot. Poultry manure is real hot. And then also be mindful that you could potentially do some like soaking or fermentation of your chicken feed to help make the nutrients in that grain, if you are feeding grain, more available to your chickens. And then that way the phosphorus in their manure would be more bioavailable. Seeds are really high in phosphorus because of that phytate molecule. And so pretty good on calcium, but you do need some more. So that's where we're going to get that gypsum going on. Again, building these numbers over time. It's not a one and done type of thing. It's just like, hey, this would be an ideal, and this is my ideal. So someone else would have a different perspective. It's just an accumulation over the 7 or 8 years that I've been studying this, what I've come up with as an ideal. And so take it as that. Okay, and I'm thinking that you're looking pretty good on magnesium. Don't add any more. I would watch your plants during the growing season to see if you're starting to see any type of magnesium deficiency. Magnesium is very important for the chlorophyll molecule. It's the center element in the chlorophyll molecule, and so it's very important for photosynthesis. And so you got to have it. If you have excess magnesium in your soil, many times your plants can't get access to the magnesium in your soil. It makes it very tight, very hard to get access. And so just kind of, you can use a little Epsom salt foliar during the growing season. If you're starting to see some evidence of magnesium deficiency, then you get a little bit of magnesium and a little bit of sulfur, and both of those are needed in the photosynthetic process. or in the whole scheme of things, to get sugars to the microbes in the root zone, which is the goal. All right, and then your potassium here looking a little low. Again, I would wait until the kind of the peak of the growing season, as you're starting to see flower show up on your plants, as you're starting to see, once you're starting to go into that pollination, fertilization stage, when you actually are needing to think about potassium, that's when I would consider doing I like to do some microbial boosting around the rhizosphere of plants to activate the potassium that's there. Making sure your soils are well hydrated is really important for potassium access for plants. And so if your plants are really dealing with ebbs and flows of drought, water, the microbial community in that soil is really minimized. You're selecting for a particular type of microbes that can live in that really harsh scenario. And they're more than likely not the ones that do all the specialty work that your plants need them to do. And so keeping your soil covered, well mulched, and hydrated. Not over hydrated. Don't baby your plants. Don't over irrigate your soils, especially if you're using municipal water, but keep it hydrated so that the microbes can live. They just need minimal amounts of water, but it needs to be consistent. Your CalMag ratio, calcium magnesium ratio, or the percentage of your base saturation, sorry, not CalMag ratio, but again, looking at this, maybe 68% would be great, 12 here. So we'd want to kind of let some of that magnesium percolate over time down through your soil profile, a little bit, but you're doing pretty good. The potassium looking good. That again will build over time, especially if you're starting to utilize any of the manures on site. And then, but be cautious over time, just do it slowly. And same with the sodium. You could add a little bit of Redmond's in a fall application if desired, or even do some of the Korean natural farming that like the fermented seawater. There are a lot of different ways that you can get a little bit of sodium available for your plants. Okay, so here boron, at least 1 part per million, at least 1 part per million minimum. Definitely want to add a little bit in the fall, a little bit in the spring. Manganese, again, this is not the most accurate reading for manganese. You more than likely have more manganese than what is here. Applying manganese sulfate to the soil, per my understanding, is not effective. It doesn't really move the needle. And so just waiting for the microbial action to get that flywheel of the microbial world to really get humming. And then more than likely, you're going to see both the manganese and the copper come up with that action. But in the meantime, don't let your plant suffer. Again, that manganese is critical for first phase of photosynthesis. Copper is critical for flexibility, for immune function, making sure that you're utilizing a well-formulated foliar in order to get those tiny little bits of magnesium to the plant, or tiny little bits of those nutrients to the plants so that they can do the work they need to do, so that the genetic potential that they have can be met. For right now, with where your phosphorus is, your zinc is looking good. This is probably going to come up over time. We'll kind of want to watch that zinc and phosphorus ratio, but this is good at the moment. Aluminum, again, one of the most prevalent elements in the Earth's crust. If your soils start to get below 6 pH or in the 5.5 pH, you can have aluminum uptake and aluminum toxicity with plants when your pHs are low, but our pHs are not low. And so it's not something we really need to worry about, per my understanding. Cobalt and molybdenum, again, that foliar application is going to be really helpful there. Again, seeing silica on a native soil, but this was a pond. Yeah. So this is more silty and it is kind of dredged, if per my understanding. And so I bet that you've got some of those reducing organisms still there. So that would be interesting to see the plant health if you're getting enough of the manganese and the iron to your plants. I didn't make note when I was there. Okay, so that's the high side of the garden. And now we'll look at the low part of the garden. Still good on the exchange capacity, still good. 6.4 to 7.2 is kind of the window of optimal nutrient availability in the soil for pH. 6.4 to 7.2. And so for now, I would just watch that again. Let's see where your magnesium is high here. And so I would continue to watch that, and getting a little more sulfur into your situation is going to help move some of that excess magnesium down through the soil profile. That'll help bring the pH down just a little bit. Microbial action is going to help with that, but you're still in a good zone here. You're not outside of the ideal quite yet. 6.4 is optimal for soil pH. 6.4 is optimal for sap pH. 6.4 is optimal for urine pH. 6.4 is optimal for saliva pH. It's an interesting phenomenon. Good on organic matter. Again, this is a new site. What was turned into the soil when the garden was made? You might have some of that residual particulate matter, but some of this, a great portion of this, I'm not sure like what happened there, but having that topsoil mound moved over there, there's a lot of churning of the soil, and you're going to have compaction that you're going to deal with for a while there. And that's where getting some really diversified cover crops going there in order to get some diversity in the root systems, some really shallow fibrous root systems, some medium fibrous and taproot systems, some really deep fibrous and taprooted plants, all of that, annual and perennial, and then cool season and warm season. Having that diversity in your cover crop can be really helpful for structuring soil because you're doing it on multiple layers. And each one of those plant families, if you've got 4 or 5 plant families represented in your cover crop mix, and you have several species in each one of those families represented there, all of those different functional groups, those plant functional groups, they associate with different groups of microorganisms. And so you have a diversity of microbes that are going to be brought into your system. This is where the core microbiome kind of comes in. Seed that is grown without excess soluble nutrients, that excess NPK scenario, they are plants that had to rely on microbes in order to be fed. And so that mother plant being fed by microbes will have already had a fully, or as much as she could have. In the world that we live in, we don't all have perfect microbiomes, but our microbiome was reliant on our mother. And yes, we built it from there, but the core microbiome that we kind of came out of the womb with was mediated by our mother. And same for that seed, the mother plant delivered that microbiome, that core seed microbiome to that seed. And those microbes that were sent to that seed are the microbes like the colostrum, like the early digestive microbes. They're the microbes that are needed for that plant in order to get going in the soil, to be able to have microbes to propagate right in its rhizosphere. They'll come out of that seed. They'll start sending out exudates before that seed even puts out its first cotyledon, its first leaf. That seed will send out exudates to attract additional microbes into that rhizosphere and to multiply the microbes that it was inborn with. And so those microbes, a diverse suite of them, are associated with each seed type. And so the more seed types you can include in your cover crop, in your garden, in your natural world, the more microbial diversity you'll have. Just like plants, they all have specialty functions. They make specialty vitamins, minerals, micronutrients, polyphenols, all this stuff. Those microbes do specialty roles as well, and they produce specialty hormones, enzymes, micronutrients, vitamins as well that the plant then can get access to. And that's where our nutrition comes from. And so having a really diversified cover crop can help inoculate your soil with a very diverse suite of microorganisms that then will support each other. If different root types, if different functional plant groups with different microbiomes are in close proximity to each other, say you've got a nitrogen fixing legume that is in close proximity to a oat plant that doesn't necessarily have great awareness, it's not building the nodules, it's not really supporting the nitrogen fixing in the rhizosphere, they can share their excesses. The grains are really well known for scavenging excess nitrogen, but they're also very well known for being very mycorrhizal. And so are legumes. But the close proximity of diversified microbiomes, in essence, the root systems of plants, their digestive tract is that root system. And so the closer those microbiomes are to themselves, to each other, the easier it is to have horizontal transfer from each one of those little microbiomes so they can share their community of microbes. They can borrow or recruit, and they also can share excess nutrients. And so having a diverse suite of plants in close proximity to each other is ideal. And that's why having a really diversified cover crop mix makes that simple. All right. And I will talk about in the recommendations, Cal, I'll talk about some foliar products that you can utilize that are well made and good stuff. All right. So yeah, I think we got through most of this. Again, we're going to need to do a little boron application in the fall. This will come up. The copper and the manganese will come up over time. But again, the foliar is going to be needed. The foliar will include a little bit of cobalt, molybdenum, that nitrogen fixing process, and then transferring that nitrogen that's fixed all the way from its ammonium nitrate up to the nitrate form that the plant can utilize in the leaf is needed. But also plants are not limited to those types of nitrogen. They can also take up amino acids, peptides, proteins. They can take up whole organisms. They farm organisms in their rhizosphere. It's been documented. Dr. James White has been documenting that very effectively with video. And so you can actually see plants taking up living microbes and cycling them through their root system and then excreting them back out into the rhizosphere. It's a really fascinating thing to watch, but they get nutrients in a multitude of ways, not just through the soil solution. All right, Tim and Michelle, here we go. We've got a good exchange capacity. The pH is high, and so your magnesium is high. Your calcium is also high. Again, with a little bit more sulfur, you're not too shy on sulfur, but 34 would be great. A little more sulfur, and sulfur, again, being a negatively charged ion, is something that is going to percolate through your soil profile on a regular basis. Because I know that you're utilizing a lot of compost, I would assume a lot of this is going to be particulate-based organic matter, plants that have been broken down into small particulate size. It also is going to be microbially digested, but not all of it. So it's going to be a mix between the two. That organic matter that has gone through a bacteria or a fungal organism will be holding on to that sulfur or that boron. And so I think you've got good holding capacity, but utilizing some sulfur inputs here might be nice. I would be mindful. It would be interesting to do a pH test on your pH or on your compost, and then also even doing an analysis on your compost just to see if it's high in any of the elements that we want to be mindful of. Our wood chips are going to be high in potassium. Any type of lignin, really structurally like stalks, are going to be high in potassium. And so wood is high in potassium. It's also can be high in phosphorus. It's high in calcium. Wood ash is really high in potassium. It's also really high in calcium. And so the hardwoods are going to be high. I'm not sure about the leaves, but I would assume so. And so I think it's like now it's get the biology really humming in the system. Your plants were beautiful though. So it doesn't mean biology is going to trump chemistry. Biology is going to trump chemistry. And so it really just depends on how things are working for the season and where you're at microbially as to whether or not any of these excesses are going to come into play. And so I would just watch that. I know that you are really proficient with your composting, and I think I encourage it all the way. Now it might be that these beds that we were testing have been adequately supplied. And so now building new beds, or the back bed back there that didn't have all of that additional input is ready for it now. And now working with cover crops, working with biological boosters to help continually break down what you've already got going here in your organic matter, keeping that cycling and doing just top dressing. If you're gonna be doing the applications on these beds, do it more as a top dressing and not a nutrient amendment. It's kind of like a little underneath your straw mulch, just as a little top dressing. In the growing season here, if the potassium was getting into the plant more and higher, if it got ahead of the calcium, and was taking up the exchange sites on the cell walls and it was kind of not letting the calcium in, then you would have started to see fruits that didn't have staying power. They either had blossom end rot or they had cell wall, like peppers can get like a sidewall kind of rot on them. You can get, it's usually just kind of quality deformities on fruit, and it doesn't have the shelf life that it would normally. If you had good shelf life, if you had nice fruit that were filling out nicely, but also looked really good visually, looked good, then more than likely you got adequate calcium when it needed to happen. And so I wouldn't sweat it. I saw your garden and I think everything looked really good. And so I think that is where it's really important. We can do some in when I come over and do the next kind of check-in, we can do some in-garden assessments. And we'll just get a little bit of an idea of where that calcium, potassium scenario is. And then we might be able to make some informed decisions from that. But I don't know that it's an issue. But I would just kind of be mindful of where you're at. And these were the most established beds. These were the 4 on the side. And so we know where those are. And boron is looking good. Look at that. That's excellent. Yeah, that's excellent. And that's going to be an artifact of having this amount of organic matter. And so that to me also says that a great portion of this more than likely is pre-microbially digested already. And so that it is more humic substance. So that's great. And manganese, again, this is not super accurate. You might need some more, but really, I think it's just getting that biology humming, and then you will more than likely see this come up. And if you're not seeing evidence of it being an issue with your plants, usually you'd see the veins of the leaf veins of your plants will be much lighter than the intervein tissue. And so if you're seeing that show up, then maybe there's some manganese issues. But again, the foliar that I had you utilize during the summer, it had the manganese in it. It also had the copper, the zinc, the cobalt, molybdenum, had those guys in there. Again, not 100% on here. You probably have more copper than what is showing. I think this is an artifact of the compost having high zinc, because your phosphorus, you might be looking okay. Yeah, so you want a zinc to potassium to zinc ratio of 10-1. And so it might be that your zinc is a little high, and that might cause you not to be able to get access to phosphorus very easily. Utilizing that mycorrhizal inoculant on your seeds and on your plant starts will be really helpful. And so utilizing that, if you decide to do cover crop, please let me know, and we'll make sure that it's inoculated. And then that'll help get that going. All right. And then Jess, we have a good exchange capacity because you're in native soil and kind of, in essence, kind of freshly broke ground. It's only a couple of years in. That I think is probably pretty accurate. Your pH being 6.7. Yeah, that's going to be accurate. Your organic matter, you're building it. It's going well. So that's good. Sulfur, again, you've got, it's not quite where we'd like it to be, but I'm glad that it's at least here. That's good. This really helps carbon fixation, complete protein development in a plant. And then for carbon to be fixed efficiently, you need to have that sulfur. Phosphorus, looking good. Again, like I said, above that 75 parts per million, I think is safe zone. So you're there, you've got access to the manures. And so you're building that, but I do want to offer that caution, right? So we've got that potassium that's starting to creep up there. So that can give you a little bit of a hindrance in the spring. And so if you were seeing any of those issues that I was talking about just a moment ago with fruit quality, then you might have had a potassium excess getting ahead of your calcium. And so if you started to see any of that in the summer, then next year you would be mindful. We'll I don't think we're doing a little bit of gypsum, but we will come in with a very plant available calcium source early in the season. And then also making sure that you're utilizing a manganese foliar early in the season to help. In the foliar that I supplied you has that manganese. It has everything in there except for nitrogen and potassium. In essence, it doesn't have magnesium, nitrogen, or potassium in it. But you'll see that a better turnout. But your garden was gorgeous. You were just pumping out lots of veg. I know there were towards the end of the season, it got a little hairy. And so that is absolutely the case when you're trying to deal with a space that big and all the things you're doing. But you were making gorgeous fruit. You were really doing awesome. But I wonder if maybe you started to have a little bit of a potassium antagonism of your calcium, and doing some rescuing of that with a calcium, a very plant available calcium foliar can help. And then also having that manganese, it's kind of, John Kemp says it's the regulator in essence. And I think Bruce Tanio was the first person who realized that manganese can be the kind of the mediator of potassium utilization in a plant. And so, yes, the mycorrhizal fungi will help, and having adequate manganese for your plant to turn on and off genes in order to help regulate that potassium uptake so they don't get it in excess too early in the season. Sodium, you're looking okay. Sure, you can add a little bit more. It's going to come in with your manures. I would be interested to know if any of your feeds are amended. Like most of the chicken feeds, I would assume most feeds have mineral nutrients. And so watching that, knowing that if you're going to have a steady source of a particular manure with an animal that's consuming a particular type of feed, and being mindful about what's in that feed, knowing that that's going to come into your compost, it's going to come into your compost and manure. And so that will be a free fertilizer, a free input. And so knowing what it is very good. And then if you need to do any buffering or remediation ahead of time, it's good to know that. So maybe we could check about that. Boron, it looks like you're going to need some boron this fall too, and a little bit in the spring. Utilizing that foliar that has all these trace elements in it is ideal. Looking good on your zinc. That's slowly going to get brought up with your applications that you're already doing over time. I am really interested in this molybdenum. So I would be interested to know, is it common in the type of manure is it in the feed? I wonder, were you seeing, it would be really interesting to look back at the garden in a photo library and see if we were seeing the sufficiency of molybdenum through the season, if it was actually showing up in the plants. It's pretty cool. Looking good here on selenium. And so this must be a feed input. And you got higher copper than most, or cobalt than most. And so this is wonderful that you have this, but it also could start to tip into excesses. And so knowing where it's coming from would be a good idea. Not to say you need to make sure that the animals consistently have it, but maybe this particular manure gets rotated around in the system and not consistently placed in the same location, so that you don't build your numbers too high. And then selenium or silica, looking great. Again, that's an indication of high microbial activity. And it could also be something that's, if you're using diatomaceous earth in any of your feeds or in your beddings, that's going to come through there. Yeah, so this is wonderful. And where are we at? We are right over time. And so I am just going to do a 1, 2, 3 quick. Sorry if this makes anybody dizzy. I'm just going to I want to make sure that I am addressing any of the cover crops. Okay, yep, we're going to talk about that in just a second. Oh, you're doing great on that. Okay, and then real quick. Sorry, please excuse. Actually, I'll just do this off screen so that nobody else has to feel really dizzy from that. Pardon me for just a second. I'm just going to look. I just want to make sure that we're dealing with everybody's topics. So Michelle, I think that's going to be the potassium with the peppers. Peppers have a tendency to take up potassium preferentially and over calcium. And so you more than likely have everything you need to grow really awesome peppers. You just need to mitigate that potassium uptake early in the season. And that can be done with that foliar, but it also can be done with some additional calcium, plant available calcium at the right time. Cover crops, Kyle, that is going to help with, it'll also help weed suppression and compaction. Both of those can be partially addressed with cover crops. You may need to do some hardcore broad forking in order to really mitigate your compaction layer. What would be good is to actually assess your compaction layer and know how thick it is, how much of an issue is it, how far down until it starts, how thick is it, and yeah, so like how far down is it and how thick is that compaction layer. And so then we know what kind of tool needs to be used for that. But breaking that compaction layer, how dense is it, is really important to make sure that you've got adequate root penetration, adequate water and gas exchange, water infiltration and gas exchange. You just want to be mindful not to you don't want to create another one down below it. And so finding out where it is and then working where you're just going right underneath the bottom of the deepest part of that compaction layer and just slicing through it. A broad fork in our systems that we're talking about here, more than likely are going to be adequate, but it depends on how far down it is, if that will be adequate. So we'll take a look. And then cover crops from Muna. We talked about that. Great. Okay. And so cover crops, if anybody's interested, this is so small, sorry. And I'll share my screen again. Let's see. Oops. Cover crops. I love a really diversified blend. I'm sure you kind of picked up on that, utilizing a little bit of everything in there. And then also cool season, warm season, perennial, annual, but it's going to be up to you guys what you're feeling. If you want to do annuals in your system, then annuals only, then that's one thing. But if you're open to doing a little bit of alfalfa or a little bit of, I don't know why this isn't showing. Let's see. Can't get it to go. Well, anywho, that's okay. You don't actually need to see that. But grasses, utilizing at least an oat, which is going to be winter kill, and having a diversified blend. And so you want to kind of have your bulk materials take a great portion of your overall blend, and then having some of the more kind of obscure things take just tiny percentages of that blend. I'm pre-blending some mixes that I'm going to contact you guys about, and I'll just find out if these work for you or if they don't. If they do, then I'll connect with you to get those right away. If you're not feeling cover crops, then let's talk about mulch to make sure you've got something to cover your garden before winter comes. But leave your living growing plants in the system as long as you possibly can. And you can oversow or intermittently sow some of these cover crop seeds underneath your already statuesque, beautiful plants, and just scratch them into the soil and get some seed soil contact. And then as your plants senesce, as we have our first frost and our beautiful veggies are taken out by the first killing frost, then just cut those plants off at the soil layer, leave the root systems in the ground. And because you've scratched in your cover crop seed, now that sun is available for those cover crops and they can just take on, and you didn't do soil disturbance to disturb them, you just removed the above ground biomass. And leaving the root systems in the soil is really advisable. That's where so much of the soil organic matter, that stable soil organic matter, gets started, is from the root systems in the soil. That biomass that's produced down in the soil itself is the first close proximity organic matter that those microbes are going to start breaking down. And so as soon as that plant is no longer vital, they're going to start breaking that down and turning it into soil right away. Leave it there and just cut it off right at the soil surface. Next season, if you're like, I don't like this stump here, take it out, but let them work on it all over the winter. And then when you go to either terminate your cover crops, if you're working with a cover crop mix that has a few perennials in it, then, or biennials, then all that can be taken care of all at once. But if you have a winter kill cover crop, then you can leave all that biomass on the soil surface as your mulch, transplant into it. Or if you are going to direct seed, you just scooch your mulch, your dead plant material off to the side, do whatever you like, put it in the compost pile if you like, or just put it in a pile and then top your soil back when it's time as a mulch, however you like to do it. Okay, so I'm going to just review, take a look at these guys, see if we had any additional questions. And if you have any questions, either pop them in the chat if you'd like, or you're also, by all means, welcome to just shout out. Cool. Okay, well, we are over time. I'm 17 minutes over time, so I hope this was helpful. I know it was a lot of information. I know it was a lot on that first soil report. Hopefully little bits were gleaned that you find helpful. And I'm here. You have access to me. So if you have any questions, just reach out. And again, if you want to set up a garden visit, I will pop right over. Just utilize the link that I sent you, and that makes it really easy because, again, it just pops it on my calendar and all the reminders are set up, and I don't have to do that part. I'm not good at that part. Wonderful. Thank you. Great. Oh, good. Yeah, totally. Yeah, Muna, just utilize what you've got there and just add to it. I think it'll be good. Okay, well, I'm going to head out, and I wish you all a wonderful night, and we'll see you soon in the garden. Bye.